Hello, good evening. Now we are all set to start our session. Hope everyone is concentrating and uh, use this opportunity to learn more from our expert, Mr. Meghan Majrekar. I request everyone to please put in more and more questions. Wherever in doubt, you can always write down your message and we'll answer those queries of yours. Handing over to Mr. Meghan Majrekar to take the session forward.
Good evening, all. This basically today's topic, webinar topic, is on pre-treatment. Basically, when we are coating on metals, different types of metals, MS, uh, the CR or hot rolled, there are different types of pre-treatments to be conducted, and some of the pre-treatments which form the base of the coating system is very important, and many of our rejections or many of our problems which occur in the field are due to improper pre-treatment. So this particular program, this particular webinar, we will be discussing more about pre-treatment masterclass, including modules on nano pre-treatment coatings. This is a Tata Steel initiative called eCafe's Qualithon. These programs are basically designed for Tata Steel customers. Their customers who are buying HR and CR steel. This particular program is more important to us who are fabricating and ultimately doing uh, liquid coating or powder coating on this. So this we are trying to guide people about technically correct pre-treatment before coating. This webinar module will discuss the inevitable pre-treatment process to be performed before liquid coating or powder coating as we have discussed. Why pre-treatment? Before any application, it is compulsory to clean the surface from rust and impurities and convert it to a better surface condition to achieve the full potential of the selected coating material. The objective of pre-treatment of metal surfaces are removal of impurities including soil scale, grease, oil, metal fillings or burr, etc. And after that, converting the surface for optimum adhesion for coatings. Types of surface or substrate. Mainly we have almost all surfaces we see around are coated for protection as well as for aesthetics. These are mainly metallics or non-metallics. Metallics, we talk about mild steel, stainless steel, aluminum, galvanized, etc. Non-metal categories, we talk about wood, plastic, walls, etc. All surfaces need some or the other pre-treatment before getting coated. In this webinar, we are discussing pre-treatment for MS substrate. Those are HR, hot rolled and CR, cold rolled. What are the expectations from pre-treatment? It is use of metals in the industries are majoritarily mild steel in form of HR or mild steel in form of CR, that is cold rolled, and galvanized steels. Impurities on metals are dust, dirt, oil, rust and oxide products. Properties which are expected are basically good adhesion, good impact resistance, good flexibility, and other resistances which are mainly the corrosion resistance or what we count as salt spray resistance or resistance to humidity, etc. Purpose of coating application is, as you know, decoration and protection. Pre-treatment is preparing a proper base for coating systems. Pre-treatment for mild steel or MS. There are two methods for surface pre-treatment. First is what we call as mechanical method, which is emery sanding or wire brushing, power tool cleaning, shot blasting, flame cleaning, etc. And chemical methods, removing impurities chemically and enhancing surface for coatings. Selecting a method will depend on type and shape of article and corrosion resistance requirement, etc. A thumb rule: mechanical pretreatment is preferred for HR, that is hot rolled steels, and castings, steels and casting, and chemical pretreatment is preferred mainly for CR or HR pickled materials. Pretreatment for mild steel. Mechanical pretreatment, also called as surface preparation, objectives is to clean the substrate of all impurities and foreign materials like oxides, rust, mill scale, etc. to create a surface profile on substrate which will roughen and increase the surface area of the substrate and increase adhesion. Need to check for surface profile depth and cleanliness level after surface preparation. These processes are usually used in protective coating applications. Surface preparation, mechanical methods. Following types of surface preparations are used for pre-treatment of metals before coating: solvent cleaning, hand tool cleaning, power tool cleaning, blasting or shot or grit blasting, high and ultra high pressure water jetting. These are international standards. There are international standards available to operate and inspect the systems and inspect the degree of surface preparation. There are these three main organizations. One is SSPC, Society for Protective Coating USA; NES, National Association of Corrosion Engineers, again from USA; and ISO is International Organization for Standardizations. This is European. Now ISO has adopted a lot of standards which earlier we used to call as Swedish standards. So on your left you have a chart showing the comparative uh, equivalence of SSPC as well as NES as well as Swedish standards. Normally for blasting we are having one specification, we call it as SA2.5. Now this SA2.5 is a Swedish or now ISO specification which says near white metal blast. SA3, or which is supposed to be the highest grade blasting, we call it as near, it is called as white metal blast, and this particular blasting is so thorough that you remove almost all the mill scales and one particular layer of HR to get the inside shiny metal visible. But in SA2.5 we allow some amount of grayness appearing from the mill scales, and these mill scales are needed to be very firm and very uh, hard sticking to the object. Let's come to pre-treatment, that is the chemical method used to clean the mild steels or HRPO materials. HRPO is pickled and oiled. Chemical pretreatment methods. Chemical pretreatment preferred for CR and HRPO sheets. Chemical pretreatment means first removing the impurities chemically and enriching the surface. This enrichment is generated by adding a thin layer of phosphate on MS surface. This improves corrosion resistance as well as adhesion to the substrate. Initially, few years back, we had only traditional methods, out of which one very popular method used to call it as 7-tank process. Now in this 7-tank process, we have 7 tanks which 7 tanks which are listed on your right. The first one is degreasing, then water rinse, then derusting, then water rinse, then phosphating, water rinse, and passivation. Now, these particular reactions over a period of time, we have changed them according to our convenience or according to our tactimes, volume requirements, quality requirements, etc. etc. So we will discuss first the details of these 7 tanks, and probably after that we will discuss why we have shifted to the new systems, what we call as 10 tank or 11 tank system in phosphating. The reaction tanks will have a definite role in process. These reactions can be at room temperature or at elevated temperature. Now that is a regular question asked by people, why should I elevate my temperature? If I can do the treatment at room temperature, why I should do it at an elevated temperature? The first reason is, when you elevate the temperature, the chemical reactions are better and faster. Number one, and number two is you can generate higher volumes due to lesser takt times available. Now, basically, the idea is, especially in North India, the winter temperatures go up to 2 degrees, 5 degrees in early mornings or late nights. And the water temperature or bath temperature could be 5 or 10 degrees or 12 degrees. And in summer, when the temperatures are on the rise and they reach about 45, 48 degrees centigrade, the bath temperature could be 35, 38. So having such a big gap and having the same timings for the reactions is difficult. So if you set your line in summers, it is going to need more time in winters for the reactions. So better you elevate the reaction temperatures, the crucial reaction temperatures, by uh, few degrees above your maximum ambient temperature in summers. So that is the basic idea why to go for hot tanks or temperature tanks. Now the first stage what we have discussed is a hot water rinse, which is not there in 7 tank, but this is a new process added into the uh, 11 tank or 9 tank process. First, the excess oil which is there, which gets removed at that temperature, usually 60 to 80 or 50 to 80% of oil which is excess will get removed without using any chemicals. Temperature will reduce the viscosity of the oil present on the job. Temperature of the job is increased for the next chemical reaction. The reaction in the subsequent stage, that is in the first degreasing stage, will happen at the full dip time, because the temperature of the job is already at higher temperature, which is the reaction temperature of degreasing tank. Now second one is either we have 2 tanks here sometimes, and that we call as KOD or knock off degreasing, and the second tank is called as degreasing. Now the basic requirement of this tank is for removal of oil from the surface. Degreasing chemicals are usually mixture of alkalis and surfactants. Oil removing action is basically the alkali will saponify and disperse the oils and cut the oil film. Now these are the oils which are uh, basically the acids, long chain fatty acids. These will only be reacted with alkalis and they will saponify. But there will be some other oils like hydrocarbon oils which will not get reacted with alkalis. There we are using surfactants or emulsifiers. They will emulsify the oils. Now good degreasing is a prerequisite of subsequent phosphate coat. If you fail to do degreasing or clean the oil and grease from the sheet, whatever next reactions you are going to have will not happen to your satisfaction. All the water in stages. Basically, these will remove the chemical carryover or chemical contamination from the job surfaces. The control carryover to next tanks. Otherwise, what will happen is my first tank is alkali and second tank is suppose acid. I'll be carrying over this alkali into the acid tank and I'll let them react together rather than reacting with my job surface. So every between every two stages, I need a water in stage. And this water in stage also, if we have it in two water in stages, usually there is a cascading done as you can see in this picture, that the fresh water will come in the second tank and the overflow of that will come in the first tank, and the first tank water will get drained to the ETP. Now this will give us number one, uh, the first tank will dilute the alkalis or acids or chemicals, and second tank will be fairly good, or quality of that water will be fairly good. So when I dip into the second tank, the contamination level in the second tank would be lesser than the first tank. So having two water in stages instead of one is always a very good condition. And there are certain conditions the water quality of industrial water expected. Now, when we say industrial water can have TDS of max 300, turbidity 2, pH should be between 6 and 8. Normally, 7 we call it as neutral pH, but it could be 1 plus or 1 minus, which is acceptable. Now, the specific conductivity. Specific conductivity has to be maximum 300 microsiemens. As less than that is the best. Chlorides, sulfates, nitrates, total hardness, phosphates, and calcium and magnesium mg per annum. Now these are the conditions which are given. Then one step better is quality of RO water. Specific conductivity expected is 30 microsiemens. This could go up to 50 because it again depends on what kind of RO system you have. But here you can see that the pH is still better, that is 6.5 to 7.2. And then what we have is the DM water or demineralized water, which is still better, where specific conductivity is less than 10 microsiemens and pH is again in the 6.5 to 7.2 range. Now what happens is whenever I have dissolved solids in water, the conductivity of water becomes more and more conductive. So as the conductivity goes on or increases, that means there are more amount of dissolved solids in the water. Water could be at 7 pH, that is completely neutral, but that doesn't mean it is pure. It can have lot of salts in it, and that indication we will only get with a specific conductivity in microsiemens per centimeter of water. Majority of the water available, groundwater available in India is having TDS more than 1500, and I know certain cases of certain places where the TDS is almost 3000 plus. If you use this water, there are going to be a lot of salts dissolved in it, and these salts which are water soluble are going to give you trouble like blisters after the paint is cured or after it comes in contact with humidity, which we will be discussing in next slides. So whatever water you are using for your system, pre-treatment system, you should check the water on regular basis or and keep a record. And if your water quality is not good, please install one RO water, at least RO water uh, plant in house, which will give you the best water, and that particular water you can use for the entire pre-treatment. The next stage, which is called as derusting. This is removal of rust or oxide products from the job. You can see that clearly in the picture also. That half of the right half of the job is treated with that and left half is untreated. There are more of disadvantages than advantages in this. Number one is this needs higher concentration. So entire article to be treated for removing even small rust spots. The higher concentration means higher consumption of chemical and water for cleaning, water rinsing. Then the fumes which come out of this particular tank definitely will harm your structures and surroundings in your factory. So basically don't use it. If at all you want to use this, there are certain de-rusting chemicals available which are phosphoric acid based. Normally HCl based or H2SO4 based or HNO3 based will hamper your productivity or hamper your surroundings as well. Now, because of these problems, this stage is avoided in new generation pretreatment lines, and de-rusting is not there. The vehicle or vehicle body which reaches the paint shop, we call it as BIW, is body in white. So there is absolutely no rust which is permissible on the jobs which are coming in for pretreatment. All of you, your sounds are muted for us, for everybody rather. Anybody having any questions, please keep on asking. After we finish this, we will go for this. You will have to type out these questions and upload it. So I'll be able to see these questions here, and we will discuss these questions later on. But as we are going ahead with this, please type out your questions. So these questions will definitely be helpful for others as well. Now this particular stage, which is very important, we call it as phosphating. This is basically a formation of thin layer of base on base metal to improve the corrosion resistance and adhesion. It forms a conversion coating which is crystalline in nature and would provide excellent anchoring to the coating. Because of the roughness, you can see the photograph is showing about 5,000 times magnification of phosphate crystals, and you can see the roughness which is created, and this roughness will give the anchoring or holding to of the coating onto the surface. In turn, it would give excellent adhesion of coating. Now there are two types of phosphating. One is iron phosphate and other is zinc phosphate. Iron and zinc phosphates are basically paint based or powder coating based coatings. Zinc offers better corrosion resistance, and so it is preferred more by the automotive industry. Now on the right side, the bottom, you can see the requirements. Coating appearance should be uniform gray, compact, fine coating. Some questions are coming. Yeah, I have some, 2, 3. Uh, Coating weight should be 2 to 3.5 grams per meter square. Please, every month or so, you make a panel, coat it with your regular system, send it to your chemical supplier. So your chemical supplier will be able to calculate or measure the weight of phosphate on the job, on the panel, and will give you the report. Crystal size is usually 10 microns, but these are needle shaped or columnar crystals. So normally they will fall down, and the total thickness in DFT, if at all we want to measure, it could be roughly 2 to 5. Now there are some questions I'll just go ahead with. Mr. Shaktivelan S. Which element in RP oil can't be removed by degreasing chemicals? Now if you have a good degreasing chemicals, basically most of these oils will get removed. In rust preventive oils also, they are majorly hydrocarbon oils and they can be removed easily with good degreasing chemicals. Only problem when people, especially in North India, people are using mustard oil for deep draws as a lubricant, and that oil cannot be removed with any degreasing chemicals. Even if you uh, do some solvent wipe before and then treat it for pre-treatment, still it is very difficult to uh, remove that oil. So please ensure that your earlier process, they don't use any mustard oil for deep draw or this kind of operations. Secondly, nowadays there are certain oils which are available in the market which we call as water miscible oils. Even they are available for deep draw pressings. If you use these kind of oils, there will be a lesser load on your degreasing uh, tanks. There's, there's one second question which is saying, is there any measure to test available to check whether oil is removed or not from surface completely other than water break test or paper test? No. I think this is the only test and this is the best visual test which you can check with is water break test. Even paper test sometimes may not be correct, but water break test will be the correct test. What will be the TDS in RO water? Usually the TDS in RO water should be less than 100 or sometimes less than 50. So it should be as low as possible, but again it depends on what is your uh, volumes or literage per hour or per day basis. Then Mr. Shaktivelan is asking if chloride of 0.22 to 2.6% was present in RP oil, will it get removed? I think it should get removed because this chloride is not water-based chloride. These are oil dissolving chlorides basically. So it should not be a problem. Mr. Prashant Kettur is asking, after surface treatment, we are getting parts in two different color, yellow and blue. Okay, we will discuss that after we finish this particular thing. In some of the last slides, we have this particular questions already discussed. There is a question from Mr. Atul Karpe. Most of the time we observe that Tata Steelium CRA steel is having black soot. CRA sheet is having black soot, okay, which is very difficult to get removed in cleaners and may leave some stains. So please let us know why there is a black soot. I think black soot carbon on Tata Steelium CR. Okay, I am not sure about this, but I'll just discuss this with Tata experts and I'll come back to you, Atul, in a short while. Mr. Mahesh Kumar is asking, we are using derusting tanks for many years. If we remove this tank, then what we install derusting is the second tank and the first one is sawdust. Mahesh Jaipur. Okay. Now this sawdust cleaning is what you're using. Sawdust is to remove the uh, oils for degreasing purpose. But just ensure that this sawdust cleaning is removing your oil 100%. There is a test given called water break test just ahead in one of the slides. Have a look at that and then again retype your this thing. But I think uh, going for dip degreasing, because this sawdust is again a manual process and it is very difficult to have the same quality throughout the day from the same person, and again the manpower becoming expensive. Probably you are not saving anything in doing this degreasing process with sawdust. Now details of stage, again the last one, passivation. Passivation, basically, if you have seen the earlier slide, you can see there are a lot of gaps which may be exposed to the base surface. Now these gaps are to be sealed with passivation, and these gaps may be, because most of the times when we are doing phosphating is a different line, and we have uh, phosphating is a different line, and coating is a different line. So sometimes we unload the material and keep it there for some time, and then we expose it to, we load it on the coating line, and that particular time you need some uh, protection, and that has been offered by passivation. Now, there are certain lines which are continuous, like CED coating line, where it comes out of the CED tank. The job is not, before it comes out of the last tank, which is the DM water tank. The job is not dry, and in the wet condition itself, we dip it into CED tank. There, it is possible that we can avoid this particular passivation, but if not, if we are drying the jobs in water drying ovens, it is better that we have the passivation there. This improves some amount of corrosion resistance. Hexavalent chrome is a environment concern, so chrome-free passivation chemicals are available. If you are doing passivation and if you are using chromes, please change it to chrome-free passivations if you are exporting your jobs. In case you are selling it in Indian market, there is no issue as yet from pollution board. But especially European countries and advanced countries, they will not allow you to use the chrome materials. To eliminate contaminations from the surface, final tip after this stage is usually DM water is. And usually the passivation also, we make the tank, prepare the bath in DM water, and there is one more rinse which is given, which is DM water. Now what does this DM water do is, whatever water soluble salts which are available on the job, they will get dissolved in this, and these will then be, uh, we will be cleaning the job, and we will be taking care of these water soluble salts, because these are the salts which will finally create your blistering, which we call as osmotic blisters. I'll just attempt a few more questions what we have. Mr. Sridhara KM, in degreasing, max remover of oil percentage during degreasing, then what frequently we have to replace the water? Now, I feel is you are talking about replacing the water rinse water. Now the replacement of this water rinse water is dependent on your pH levels. If the pH, usually we say that 7 to 9 pH is allowed or acceptable, sometimes up to 9.5, but beyond that, if the pH increases, that means instead of that water we have alkali there, and that alkali will move into the next tank, and that those two chemicals will react with each other rather than reacting with our jobs. So it is better, that is why I was just mentioning that having two water in stages can reduce this or eliminate, I will not say eliminate this, but reduce this for sure. Mr. Digambar Sapre is asking how to clean the welding surrounding areas. Now, welding surrounding areas, basically, number one is the black parts which are developed are mainly because of the oil which burns, and removing this burnt oil is difficult or impossible with this chemical treatment. So you have to ask your people to clean the oil before welding, at least the area which is adjoining that particular weld line. could be about say 1.5 inch on either side. They can wipe out the oil, clean the oil, and then go for welding. This oil will not only hamper your burnt oil, but they will also hamper your welding quality. In welding, you will get a lot of blowholes and other things, undercuts, blowholes, or sometimes more ripples. And these defects will definitely give an early failure to your coatings. So you have to work little backwards at welding. Mr. Prashant Kettur is asking, we are cleaning electroless nickel coated parts in pretreatment. Does this coating strength reduce after pretreatment? I'm not sure. I'm not sure how this all the chemicals will react with electroless nickel. Basically, because there are alkalis as well as acids in that, and I'll have to check the reactions of electroless nickel uh, with these individual chemicals. Again, from supplier to supplier, chemical supplier to supplier, we don't know what kind of oils or what kind of additives, what kind of surfactants they're using, and how good they will behave with uh, electroless nickel is a area we need to study basically. Mr. Sridhara KM is asking, if oil is not removed, what type of problems will occur? We will come to that basically. But if the oil is not removed, you will not get a good phosphate coat, number one. And number two, you will not get a good adhesion of uh, either liquid coating or powder coating. The failure will be much faster, and naturally the corrosion resistance also will fail in those areas. Mr. Shaktivelan is asking, will there be salts in RO water? How much mg per liter? Okay, this is basically, it's not, I'll again go back to that slide. You can see that the specific conductivity is 30 microsiemens. That means there are some salts. If salts are not there at all, the specific conductivity would be as good as zero, because water becomes insulating when there is no dissolved solids in that. When you start adding the solids, that water becomes conductive and we start calling it as electrolyte. So in RO water, if the permissible conductivity is 30 to 50, there would be some amount of salts available in that. The next question is from Mr. Mahendra Rawat. Most applicators do a sanding or wiping with abrasive materials. This will destroy the phosphate crystals. Why do chemical supplier encourage this practice? Absolutely. Very good question. In fact, this is not a question, this is a very good remark. And Mr. Rawat, I definitely appreciate your viewpoint towards this. Yes, people do use sanding or wiping with abrasive materials like Scotch Brite or things like that. Or I've seen even with those stainless steel wool, people rub that material. But mainly why they do that is they get the powdery phosphate coating, which we are discussing in the next slides. Again, Mr. Rawat is saying in the de-rusting stage, many applicators use commercial SCL. What effect will have on the coating performance? Now, this particular SCL, basically SCL or any other strong acid, basically will, if it by chance goes into the gaps or the cracks in your fabricated jobs, like between the two sheets, if you have some gaps there and it remains inside, the corrosion will be much faster. And SCL will clean definitely, but it will not give you a very good phosphate also, because it is going to make it more and more reactive. So the phosphate layer also will not be uh, very good. Some applicators use HNO3 dip after zinc plating. What is the effect of quality of HNO3 on the performance of coating? You mean to say that HNO3 after dipping into HNO3, they're doing some coating on that. So probably they're doing it for etching purpose. And I don't think HNO3 should be used. Nitric acid is quite difficult acid. All HCl, HNO3 as well as H2SO4 are very difficult acids. Now Sridhara is asking, Sridhara KM, for HR material parts, which type of pretreatments is preferred by Venkatesh? Okay. This particular question I have already asked in earlier slide. If you have missed it, we have to go for either blasting. There are certain methods of your mechanical pretreatment where you can use emery sanding, or you can use hand tools, power tools, or sanding, or blasting, or ultra pressure uh, uh, ultra pressure jets blasting. So, or you choose the PO material, that is pickled and oiled HR material. Mr. Sudhakar Pokharkar is asking, is there any system available to reuse the derusting chemicals or to reduce iron content? Is there any system available to reuse derusting chemicals or nothing that I know of? Nothing that I know of. I think you can put this question. I'll uh, uh, I'll discuss with some experts and give you the answer of this. Mr. Bishwajit Thakuria is asking, what is the major cause of rusting even after doing PT line after a few days? Okay, I'll come back to this because our presentation is covering this particular point. Now, looking at this, here we are with a fresh flow chart, which you can just refer to as first is hot water rinse, then knock off degreasing, then degreasing. This is actually you can call this as a three-stage degreasing, then a two-stage rinsing, then you have a surface conditioning, then phosphating, then industrial water rinse, then passivation chemical usually prepared in DM water, and the last is DM water rinse. Now this can be a very good system for your purpose. And here basically instead of we have removed the derusting from somewhere from this particular stage, then this derusting used to activate the surface. Now since we have removed derusting from this particular line, we have to add a tank which we call as surface conditioning. Now this surface conditioning will activate the sheet metal for a better layer of phosphating, better reaction of phosphating. Along with that, it also will give you a very good, what to say, uniform phosphate crystal formation, which is desired actually. There are a few more questions. Mr. Ramesh Chavan, for derusting chemical require agitation or not? Very good question. Basically, since we are talking about high strength oils, uh, hardly any pumps which are available to do the agitation. Even if you use stainless steel pipes with air agitation, uh, you don't get it very good. But you need the agitation when you prepare the tank. When you are adding the chemicals into the tank, you need to agitate it properly. For reaction, you don't need a very good agitation. Mr. Next question is Mr. Sridhara came again. Why the black spot observed after plating in HRPO material? Basically, these black spots may be your either pitting is there on HR material, or original HR material, or your HRPO material, the 100% of your mill scale is not removed. That is the reason sometimes you see those black spots. Mr. Bishwajit Thakuria, how frequently we need to replace RO water for degreasing, phosphating and passivation tank? Uh, you mean how frequently you have to discard these tanks or replace RO water? I did not get your question very correctly. But degreasing tanks, phosphating or passivation, usually your chemical suppliers will give you the discard frequency and you have to stick to that. Basically, if you're talking about discarding or replacing the RO water in the rinse tanks, water rinse tanks, then preferably you should have a control on pH. Whenever the pH is going above the level, out of the range, you have to add the fresh RO water and you need to drain the existing water. And usually that overflow is good enough to do that in all the tanks. Mr. Sridhar is asking, in pretreatment, if we are using hot phosphating in beginning stage, is it necessary that we have to treat the part from hot water only? Uh, you are asking, probably you want to ask hot degreasing in the beginning stage. Is it necessary that we have to treat the part in hot water only? No, it's again depends. If you have a very high amount of oils on your job, especially if you're doing deep draws, and if you have very complex shaped jobs, only two tanks might not be sufficient to do the degreasing. That is, KOD and degreasing will not be able to do the degreasing. So, adding one tank, which is your uh, hot water tank before, is better. Number one, it will give you the temperature of the job elevated to the reaction temperature in the KOD. So when you dip it in QID from the first second, the reaction will be at full potency. Otherwise, what will happen if you dip it at lower temperature, ambient temperature, say 20-25 degrees, into a tank which is 45 or 50 degrees, few seconds will go to heat up the job, and after that the potential reaction will happen. So if you are having 3 minutes or 4 minutes of treatment time there, you will really not get the full 3 or 4 minutes of treatment. Instead of that, you will get only half time of that in the first tank and full time in the second tank. So better you go for hot water tank there. Mr. Harish Mahendra Rawat is asking, in the degreasing and phosphating baths, people use air for creating turbulence. This will introduce oxygen and carbon dioxide. How will this affect the efficiency of chemical? Is this better than mechanical stirring? Actually, better is to pump. In degreasing, you need to create this kind of vertigo, a linear motion of the material of the chemical, so that whatever oil is separated, which comes out and comes on the one side of that. I think there's one small photograph picture in one of the next slides where I can show you. And again, people feel that air is amply available, why not to use it instead of pump? But air is more expensive than electrical energy, which they don't really uh, realize. And one more thing is, again, as you said, that we are introducing oxygen and carbon dioxide, which may oxidize certain chemicals into that. So probably, I don't think this is a very good idea. Mr. Shaktivella Nest is asking, will the corrosion inhibitors added in RP oil cause any problem in degreasing? Is there a chance of carryover in parts without getting degreased? Okay. Normally these inhibitors, if the oils get removed, the inhibitors also will get removed because they are very well dissolved in RPOI. So I don't think they should cause any problem. And the carryover, if the oil gets carried over, these inhibitors will also get carried over. So better you have a very good cleaning at this stage or oil skimming here at this stage. What should be the distance between different tanks in PT line? I mean, nothing specific about it. You should have it next to each other, probably a distance of say 100 mm or 200 mm should be good enough, but that's all. I mean, it is not mandatory or it is not important. Again, back to the presentation. There's a new generation PT or nano process, what is called. Now, this particular process was generated or was invented in Germany, European countries. Basically, the reason was getting reduced sludge because disposal of sludge was another problem. So it was important to reduce the sludge as well. So this particular nano system or nano process or next generation pre-treatment was invented. Now this particular treatment is not like phosphate which is crystalline. This is an amorphous coating, and being the amorphous coating, the layer is in nanometers. That is 1 mm. If you divide to 1000, it is 1 micron, and 1 micron you divide by 1000, it is 1 nanometer. So this particular coating is literally very small, 50 nanometers to 200 nanometers is the range. It will of course vary a little bit with company to company. There are only 3 or 4 companies who have a established marketable product at present. And the advantages are written here. One is the very short treatment time, only 60 seconds. This is a room temperature process. Now, one thing is there that you have a very large range or a large thickness range, that is 50 to 200 nanometers compared to phosphate which is 2 to 5 microns. So naturally your process is very flexible here, so you don't need to heat it up. You can literally achieve this in 60 seconds or even less time also sometimes at room temperature. So that is energy saving. Surface conditioning and passivation is not required in this, which is another beauty of it. You don't need passivation because this is not crystalline, this is amorphous, and you don't need surface conditioning. Then there is very little or no sludge. I mean, one of the plant, one of my customers is running. Uh, in 6 months, we clean the filters and the entire sludge, whatever we generate, is not more than 2 to 5 kgs in 1 year or in 6 months rather. So you can definitely say that very little or no sludge. Then heavy metal ions are much lesser than phosphate bar. So there is a very less load on ETP. Paint performance is excellent, and this is a multi-metal pre-treatment. So in the same baths or in the same process, you can use MS or galvanized iron or aluminium or SS, etc. So these are some advantages of nano phosphate coatings. Some of the reports say that by 2022 or maybe 2025, phosphating by itself will get eliminated or banned, like chromes or like lead, what has become banned now. So, if you are putting up or thinking of going for a new uh, PT line, pre-treatment line, please consider a nano coating there. It will be having certain difficulties, like you need a lot of DM water. Then your first 3 times I'm considering as hot water, KOD, derusting, then water is. These 5 tanks can be MS. After that, there will be 4 tanks which have to be in stainless steel. So that is investment is little on higher side, but there won't be any alternative also to this. Mr. Ramesh Chauhan is asking, sulfuric acid based derusting chemicals are a big problem as due to high reaction property. Pipe pH leakage as a big issue. We are trying to use phosphoric acid base. Will it reduce the SST hours life? Please confirm. No, not at all. It is only the reaction will only give you the removal of rust. So it is nothing to do directly with your SST life. Your SST life will depend on the phosphoric acid or phosphating tank performance. Mr. Ramesh Chauhan. Mr. Mahendra Rawat is asking if nano suitable for HDG. Yes, it can be used for hot dip galvanizing. There is no problem. Mr. Mahendra Rawat again, unlike nano process, phosphating will give higher crystal size and better anchoring. Your option. Uh, uh, yes, what you say is correct also, but the adhesion and other performance on nano was found equivalent, then only it was accepted by majority of the industry. Otherwise, it wouldn't have been accepted by the industry. Mr. Mahendra Rawat again asking if zinc phosphate gives 1000 hours salt spray resistance, how much can the expected from nano PT? Again, the same answer is unless and until it gives the same performance, even to some extent same cost, no industry will accept this as an alternative. Nobody will go unnecessarily for more expensive coating, and nobody will reduce their performance criteria just to go for this coating. So since even automotive industry has now accepted this, I don't think this particular question stands anymore. Mrs. Sudhakar Pokarkar is asking if GI surface required coating formation before painting process or only degreasing is sufficient. Okay, a good question. GI surface will require a process which is normally called as chromatizing. Chromatizing is micro etching of the surface in which the coating will hold good. Again, the degreasing for GI will be not the regular which we use for MS, because the alkali, higher the alkali content, it will react with the zinc on GI. So usually what we have is the surfactant based degreasing chemicals which are used for this particular GI and hot dip galvanizing materials. After treatment, how many hours we can keep the part as exposing to air without powder coating? Mr. Sridhar or KM. Ideally 4 to 6 hours. Some people claim 16 hours. But again, when I'm telling you 4 hours, I'm considering the worst of the humidity conditions and worst of the ambient conditions. But till 4 hours, you should not have any issue. But if you are doing it, because many places I've seen that people will finish their phosphating in the first shift end, and next day early morning they will load it for powder coating. That should be avoided, because during evening and early morning the condensation can happen, and condensation will give you some amount of corrosion which will start under the coating. Mr. Shakti Velan is asking, If chrome-free solution is applied over galvanized steel, then is phosphating required? I am not sure I have understood this particular question. Because chrome-free, what we are talking about is passivation. It has nothing to do with phosphating. It is to be done after phosphating. So I think you can rephrase this question and send again. Mr. Sudhakar Pokarkar, is alkali resistance of paint is depend on the phosphate coating quality? Not really. Not really. Some paints which, for example, if you have a good epoxy paint, that will have a very good alkali resistance. But if your pre-treatment is not very good, any coating is going to fail for anything else. So ideally, you should have a good uh, pre-treatment so that all these resistances work very well. Now here I have a few, 2-3 slides showing you the general comparison between iron phosphate, zinc phosphate and nano coating. The first characteristic is coating. Iron phosphate is surface conversion of the surface. Zinc phosphate is the crystalline coating over steel surface. And nano coating is the amorphous noble metal oxide. Color. Iron phosphate will be violet, bluish or sometimes yellowish color, amorphous coating. Zinc phosphate is grayish color and nano coating is sometimes violetish but majority golden yellow or colorless. Coating weight is 0.3 to 0.8 grams per square meter. Zinc phosphate is 1.1 to 4 or 2.5 grams per square meter. Nano coating is 0.1 to 0.5 grams per square meter. Sludge formation, iron phosphate, very little fluffy sludge is deposited on components. Zinc phosphate sludge formation proportional to coating weight, more crystalline. So it's a byproduct and this sludge formation is a white powder. In nano coating, as we have already discussed, is no sludge at all. Multi-metal components, MSGI, zinc and aluminium. Iron phosphate can be treated. Zinc phosphate has limited application there. Nano coating can be treated. Characteristics again, bath temperature. This is usually room temperature. This is ambient to 45 degrees or sometimes 50 degrees in some of the phosphates. Nano coating is again at room temperature. ETP is you can neutralize and dispose. Zinc phosphate neutralize sedimentation, filtration with hazardous weight, iron phosphate sludge required, and nano coating only neutralization is required. Operational flexibility, this is flexible. Zinc phosphate is a little bit flexible, but nano coating is quite critical basically. Stages, less stages. Zinc phosphate, you have more stages, and nano coating, you have slightly less stages, but more stages than iron phosphate. Best system would be about 9 stages. DM water not required, not required, but here you need, for nano coating, you need DM water. That is must. Now here you can see the pictures. This is typical iron phosphate coating. This is a zinc coating. This is slightly on the darker gray side in the photograph. Actually, it could be slightly lighter side also. And nano coating, this job actually was golden color, but the photograph is not showing it literally as it was. So these are the major comparisons between these three types of oils. Let me attend some questions here. Mahendra Rawat is asking, die-cast aluminum contains silicon added by design. How does it affect the performance of pre-treatment and what is the maximum permissible limit? I don't think I'll be able to answer this question right away. But this silicon, if it is embedded well into aluminium, there should not be any problem. But sometimes when in case of aluminium only, when it is welded, especially the aluminium radiators, this particular silicon floats on the welds, and then they create a adhesion problem. But nothing to there, you cannot do anything with pre-treatment on that. You cannot remove that silicon with pre-treatment. Mr. Vipin Pathak is asking, is the result for xenon arc test treating CRMS is same in the tricatonic phosphating or nanophosphating? Actually, xenon arc test and treatment of CR and MS, probably there's no direct relation there of phosphating and nano coating, nano PT, because actually xenon will attack only the top coat, not even the uh, not even your primer. So this is way below primer. So I don't think that should give you any adverse effect as such with xenon arc. Mr. Siddhara came as asking, dipping or rinsing of parts in each tank, is any particular timing is decided which will give you good results. That is 99% of okay parts after powder coating. Let me read it again. Dipping or rinsing of parts in each tank, is any particular timing is decided when will we give the good results. Okay. I mean, again, some offline remarks, let me say, is if your job is in degreasing tank for more time, it is good. But if you do not keep it for that much of time, which has been established or which has been told by your chemical supplier at that particular temperature, the reaction will not be complete, and you will still you will do the action or reaction, but that oil will still be on the job, and that becomes a problem. So you will not get good results after powder coating. Similarly, same as in say phosphating, if you keep it for more time in phosphating, the phosphate layer will be thicker. Thicker in the sense, instead of 2 to 5 microns, it could be 8, 10, 12 microns. And there are chances of delamination of that because this phosphate layer are crystals on each other. So excessive coating of phosphate will be more brittle, and adhesion could be a problem. So better stick to whatever your chemical supplier has asked you. Mr. Mahendra Rawat is asking, many applicators use the curing over or water dry off. How will the high temperature 180, 200 affect the nano coating? Actually, will not affect nano coating. I don't think it will affect nano coating, but this question was, I mean, for the first time, I am also asking myself this question. What I'll do is I'll check with the chemical suppliers and let you know again, because this is something never struck me. But what I feel is whenever we are doing this pre-treatment and for example for powder coating it goes up to 220 degrees. Naturally this coat, if something had to happen to this coating at that temperature, it would have failed even after powder coating. So, and usually water dry or WDO1, what we call as, is designed at 110 to 120 degrees, not 200 degrees usually. But sometimes I know some people do not have a separate water drying oven, so in rainy seasons they use this regular oven for water drying. But this is a good question. I'll confirm again. HR parts are mechanical process or chemical treatment. Please explain, Mr. Sridhar Akyam. HR parts, if it's a pure HR, it has to go through mechanical process. Sometimes we are doing mechanical process, that is blasting, and after blasting we are treating it for chemical treatment. But mechanical pre-treatment is a must because the Mill scales over that cannot be removed. Okay, Mahendra Rawat is saying curing oven. Fine. So I think all the questions here are over at this point of time. Some more questions also might come, but till that time we'll continue with our presentation. Now, good pre-treatment. Maintain the chemical strain, temperature and time. Is it enough? So according to me, it's not enough. You need to check for oil content in the degreasing baths. Then you have to check for phosphate sludge and check for rust. These can be visual rust, visual test. Now this particular slide, you can see some pictures. Oil skimmer unit for degreasing can be installed. Now have a look at the right side top figure where basically you can see the water agitation has a linear flow. That is, at the bottom it is going to the right and from top it is coming to the left side from right. Here what happens is whatever oil which is available, which is floating, will go into the drain or a gutter which is built into the tank, and that only that water we will take out and treat it for water skimming. Okay, and we can skim off the oil and again that clean water or clean chemical can be taken back. Now two photographs of installation of similar thing is also you can see here at the bottom. Now the oil content which remains as emulsion into that particular tank. Some of the oil will float, some of the oil which saponifies will get converted as scum, and rest of the oil will remain as emulsified in emulsified condition for longer time inside that tank. Now, if that oil content goes above 4%, normally 4%, because again your supplier to supplier there may be some variations, you have to discard that. So, if you don't have the oil skimmer or oil separator in your system, naturally the discard will be very frequent. So it is better you install this because cost of chemical is more than installing one oil skimmer. Then this is a phosphate sludge. The filter press of about 20 microns of filtration capacity can be installed. Now usually what I observe in the industry is on weekends people will take out the upper chemical into the next tank and the remaining chemical with sludge they will drain out. Now that chemical could be about 10 to 5 to 10% of your bath volume. Cost of phosphate chemical is very high and you are throwing that chemical unnecessarily just for getting rid of the sludge. So basically, if you have this kind of filter press, I think you don't need to discard your chemicals, and the cost of that will be uh, saved. Okay, Mr. Mahendra, you had asked the question, and thankfully, one Mr. Atul Karpe, who is expert from Chemical Rai, has answered it on the spot. Thin film will withstand temperature up to 280 degrees centigrade as it is amorphous, no risk of any crystal breaking. Okay, I think you have got the question. Thank you, Atul. Thank you for immediately replying this. All chemical suppliers saying 120 degrees for WDO, not more than that after PT. Our processes depend on powder curing temperature like 180 degrees for 10 minutes. In that case, is there any effect on PT layer? No, I don't think after you coat with powder there is any effect on PT line. Otherwise, it would not have been recommended for powder coating at all. Mr. Shaktivelan, what are the probable reasons of failure of degreasing process that can result in field failures after 4-5 months inside usage? What is the probable reason of failure in degreasing process that can result again the same 4-5 months inside usage? Sir, basically this not getting your oil cleaned is the main reason. That's all. And there may be various reasons because you might not be having correct pointages. The concentration is usually called as pointage, or your temperature is not proper, or the oils what have been used on your job while deep draw or pressing or any other operation. You can go back and check them. They may be very tough, for which the degreasing chemicals are not designed. So maybe that is the reason you are not getting it correct, and that should be sorted out discussing with your chemical supplier basically. Mahesh Kumar is asking, have any environment concerns of coating if discarded it in drainage? Yes. Uh, which one are you talking about? If you drain it, you cannot drain anything officially. It has to go through ETP. So we are always saying that if you shift to nano coating, the load on ETP is less. But ATP treatment is there. So any chemical or any effluent you generate in your factory, if you throw it in drainage directly, it is not acceptable. Mr. Sridhara KM, plating process for HR material, what type of treatment is adequate? I'm not sure basically because I'm not a plating expert basically, I'm a coating expert. Both of them are different core knowledge based technologies. But I think you can go for some of the HR, you can go for some kind of mechanical treatment like buffing, short blasting, or fine short blasting, and then you can do this thing. But even for plating, sometimes they're using again acid pickling also they're doing, and after that they go for plating. Yes, Mr. Mahesh Kumar is again asking for nano coating. Yes, but you have to pass it through ETP. That is a compulsory. Mr. Sudhakar Pokarkar is asking, what is the effect of carryover of de-rusting chemical to phosphating stage? Is there any limit? Actually, no limit because you have to control your water rinse tanks. And usually, if you have a de-rusting tank, we will always recommend two rinsing tanks after that, two water rinse tanks after that, just to control or just to avoid the de-rusting chemical going into phosphating stage. Now again here, if you are using a phosphoric based de-rusting, the risk is lesser. But if you are using HCl, HNO3 or H2SO4 based, the risk is more. So please, please, please don't do that. Mr. Sudhakar Pokarkar, how we can decide bath life of iron phosphate tank? Basically, you are not supposed to judge that. You have to discuss with your chemical suppliers, and he will tell you. We also check the iron content and things like that in labs, and they will give you an idea that after so much of uh, pre-treatment or so much of square meter of material, you'll have to discard your tanks. So be closely in contact with chemical suppliers, and they would be glad to help you out with this particular question. Now, problems during pre-treatment, improper degreasing. I think a lot of people were asking about degreasing, and water break phenomena is observed on the component. Now, after degreasing, when you put it in water rinse, and when you pull it out of water rinse tank, you have to check visually. If it's a manually operated process, well and good. But you have to check that there is no water break happening on that. Now check for degreasing bath concentration, temperature may be lower than specification or higher oil content in the bath. Sometimes if you don't have proper oil skimming, the oil will keep on floating on the uh, parts, on the tanks. Your part will get dipped, will get cleaned, but when it comes out, that oil will get redeposited on that, and you may face this problem. So that should be avoided. Problem during pre-treatment, yellow or rusty phosphate observed. Now, this photograph, you can see this, that sometimes what happens is the water remains on the job, lingers on the job for longer time, doesn't dry immediately. So some kind of tarnished or what we call as flash rust can happen on that. Sometimes the job itself is rusted previously and derusting is not adequate, then it can happen. Your surface conditioner is not in condition. Either it is ineffective or it is very much diluted or not working properly, or in your phosphate bath, the higher free acid and lower total acid, the ratio of T and EA which has to be maintained, which is not getting maintained, so this can happen. So by adding accelerator, etc., as per your chemical supplies suggestions, you should correct your uh, tanks. Powdery phosphate coating, you can clearly see this, and this is basically if we don't put that filtration system on phosphate, this can happen, and this observes only in zinc phosphate. You will not see this in iron phosphate or even in nano coating. And sometimes, as I think Mr. Mahendra Rawat was saying, that people will scrub it with something and then there'll be a problem. So it's you are removing the phosphate layer, number one, and you're doing a lot of handling, so probably you are contaminating the surface again. So that is also not a very good condition. Incomplete phosphate coating. Basically, the phosphate coating is not formed completely on the surface. Sometimes base metal and bluish color is visible. Sometimes improper degreasing. Sometimes improper surface conditioning. Or sometimes drying is happening in interstage zones. Again, here the FATA ratio is a problem or temperature is lower. One of these conditions will give you this incomplete phosphate coating. Then contaminations. There are some paint films sometimes will show certain. This is one of the photographs. There are many more which can be seen under this contamination thing. Sometimes you see some ring type behavior or sometimes some dripping type of behavior, and this is basically degradation of water quality. If your water quality is not very good, you get sometimes this kind of behavior. And these kind of blisters, what is shown in the right side bottom picture, these are usually called as osmotic blisters. The salts which are there in water, they will get deposited below the paint film. Now all the paint films or even powder coating films having um, some kind of permeability to humidity, and the in the humid days or after some days or some time of water immersion, these salts will pull the water humidity. They will become damp. After that stage, they will become a salt water, and this salt water, if there is salt water underneath the film, um, the osmosis will start, and it will start pulling the um, it will start pulling the humidity faster, and at that point the paint film will blow. We call it as blisters. So this can start because of the salty water inside. The rusting also will start very fast underneath that blisters. So this is very important that you should have uh, clean water or DM water at least at the last stage. And you should avoid the salts in the water. So quality of water plays very important role in case of pre-treatments. I think for the time being, that's all from my side. Uh, there are some more questions we would attend. Mr. Prashant Kettur is asking, we are receiving powdery components after pre-treatment in iron phosphate coating. I don't think it is possible. But I think this needs to be checked because is this a white powder or grayish powder that you just type it out and we will discuss more. Okay, Mr. Atul Karpe is complaining there is some issue with your audio, or maybe possible because of the internet connectivity. Uh, but I'll just check it. For me, the screen is showing the audio is good, but there may be some internet connectivity problem. Then Mr. Mahendra Rawat is asking, sometimes shiny crystal-like appearance is seen on phosphated surface. What is this and how will it affect the paint performance? Sometimes shiny crystal structure is formed. Yes, I've seen that. But most of the time, your uh, phosphate layer is thicker, and those are very big crystals which happen, and that will definitely affect the paint performance because too thick phosphate coat also is not very good. Mr. Mahendra Rawat again. Some applicators store the phosphated articles in the pretreatment area. How will it affect the performance? Uh, as we already discussed that you should not be doing storing it for more than 4 hours. You have to finish it within 4 hours. If you store it for more than 4 hours, the micro corrosion will start inside the coating and which may not be seen by bare eyes, and after that on top of that if you coat probably you will have an issue, so better don't do that. I think majority of the questions are also answered. uh, Anybody with any questions, because we have finished up with the presentation and now there is time for question and answers. I think there are no more questions. Anyway, because people were more interactive and they were asking the question right away along with the slides, so probably there are no more questions from anybody coming up. But I think I'll wait for another 5 minutes. Any more questions are there, we'll definitely answer that. Yes. Okay. There's a compliment from Mr. Vipin Pathak. Thank you, sir. Nice webinar. Okay, thanks a lot, Vipin. You're welcome. And probably uh, we will have you on this kind of webinars on coating field from Tata Steel quite often. How tan is important with respect to stain creation while storage of coil. I don't know this actually. I've seen this question, but I haven't answered before because actually I'm not really sure about this. But Mr. Raju, I think I'll talk to Tata Steel experts and I'll reply you back on this particular question. Right? Mr. Prashant Kittur is also saying thank you, sir. So people have already started saying goodbye. Mr. MBN Raju again, this is reference to CRCA coil supplied to automotive customers. Okay, fine. So basically, all these questions will be stored and saved at our end. So whatever questions are not answered, there are two questions. One of it, three questions. One question, Mr. Atul Karpe from Chemical immediately answered, and there are two questions still unanswered. So I'll definitely come back to you, sir. Mr. KM Sridhara is saying thanks, good interaction, better clarification. Thank you very much. And thank you very much for asking so many questions, sir. I mean, unless and until those questions were not asked, probably it couldn't have been so interesting. Then Mr. Shaktivelan is saying, what are the processes to be checked when we fill your samples to find root cause? Okay, sometimes see, again, coming back to paint technology as such, is it's very difficult to get to the root cause always in paints, and sometimes the failures are after 6 months, 8 months, or few years. So that time it really becomes very difficult to trace back the root cause. So I think it is always better that we do something on proactive basis and control our process parameters so that naturally our some of the uh, defects which can occur are under check. Mr. Digambar Sapre is asking cost comparison of nano versus conventional phosphate coating. Now, suppressor thing is basically majority of automotive industry has also started accepting nano. So indirectly, you have worked with Tata Motors for so long, so I know how conscious automotive industries are uh, about quality vis-a-vis cost. And if majority of auto industry has started accepting, probably the costs are acceptable or costs are at par. Now, just let us discuss in two, three short points. One is we are not hitting it up, so some of the cost goes down. Then it's a 9 tank process, no activation, no passivation, so that cost you can reduce from nano coating this. Then ETP cost and disposal cost of phosphate sludge. That cost also you can take out. So after that, probably the both the cost will match, and probably if Mr. Atul Karpe is still online, he would give more. He would enlighten us regarding this particular cost aspect. But I think what I have judged for you should hold good. And Mr. Sridhara is thanks for good interaction and better clarification. Thank you very much, sir. Thanks a lot. See you again in our next webinars. We are doing webinars on various different types of coating related activities, liquid coatings, powder coatings. This time we felt that pre-treatment is most important and most required, and majority of the places I visit, I see there's the pre-treatment is a big issue everywhere. So we thought that we should emphasize on pre-treatment this time so that we can have better interaction with people. Mr. Shaktivelan is asking what are the processes to be checked with field failure samples to find root cause. I think we have already discussed about this. Mr. Shaktivelan is saying thank you very much for your presentation. Thank you, sir. Mr. Mahendra Rawat is saying thank you, was quite informative and useful. Thanks, Mahendraji. See you again. Mr. Mahesh Kumar, discussion. Mr. Surendra Saini, we are having 7-tank process where there are no hot water degreasing and KOD tank. The samples after degreasing do pass water break test. Uh, you still recommend? No, sir, we don't. Mr. Yogesh Gupta is asking this. No, sir, if you have a simple job where oil presence is less and you are not into EDD, that is extra deep draw or deep draw pressings, and you are not adding any oil in the earlier stages, one tank degreasing should be good enough for you. Don't add anything, no need. If you are really confident that your degreasing is happening correctly, don't do anything. Mr. Ram Patel from Jotun is saying thanks for good session. Sudhakar Pokharkar is saying thank you very much, sir. Digambar Sapre is saying many thanks for interactive session. Mahendra Rawat, will your slides be available on website? Yes, we will try to put those slides on the website so you can have that for your knowledge sake. You will have to visit www.ecafes.com and there you will have this. Mr. Surender Saini is saying thank you very much, sir, for very informative talk. Looking forward to uh, future webinars. Yes, sir. We will see you again on next webinars. Many thanks, Mr. Meghanji, for your organization. Yes, thank you very much, Mr. Mahesh Kumar, and we will expect you here on in our next webinars as well. And thanks everybody for asking good questions, relevant questions, and timely questions, because that has actually made this particular webinar very interactive and very interesting to others. I know there are a lot of people logged in, but very few of them were really active, and those who were active, well, they've really helped this presentation to be uh, good and useful for most of you. Thank you very much. Thanks a lot.